Hi, this is Scott Wilkinson, host of Home Theater Geeks. In episode 230, I chat with Brian Vessa about the recent SMPTE report on the state of cinema sound and its potential future. So stay tuned.
Netcasts you love.
From people you trust.
This is Twit.
Bandwidth for Home Theater Geeks is provided by CacheFly at CacheFly.com.
This is Home Theater Geeks with Scott Wilkinson, recorded October 30th, 2014. Episode 230, Cinema Sound Now and Beyond. Hey there, Scott Wilkinson here, the Home Theater Geek and editor of avsforum.com. This week's guest geek is Brian Vessa, Executive Director of Audio Mastering at Sony Pictures Entertainment and chair of the SMPTE committee that released the report on cinema audio systems that we talked about last week with Brian McCarty. But I wanted to get Brian Vessa on today to talk a little bit more about that report and where we're going in the future. Hey, Brian, welcome to the show.
Hey, Scott, thanks for having me on.
So glad to have you here. Now, those who are tuned in to the live video stream at live.twit.tv or logged into the chat room at irc.twit.tv can post questions for Brian as we go, and I'll pass along as many as I can. So we're going to talk again about the report from SMPTE that was released 2 or 3 weeks ago now, 3 weeks probably, on the state of cinema audio and how it's been done up till now, what the results of a bunch of measurements were. And really, more importantly, in this episode, we're going to recap a little bit of that. But what I really want to focus on here in a little bit is where are we going in the future? How are we going to fix the problems that were identified? What about immersive audio? There's a ton of stuff to talk about here. So, Brian, why don't you give us a really quick recap of what the report showed, what it was about, why did you do it? Why did you undertake this pretty large task to measure a bunch of theaters and do all the stuff that is in this 200-plus page report? Give us a little synopsis. All
right. So, you know, a group of us noticed, and Brian McCarty was one of those who was on last week, definitely that, you know, sound was quite inconsistent between theaters. We hadn't really touched the standards for quite a while in theater. The standards were kind of written in the 70s. And, you know, we were noticing that, you know, if you mix a movie in a dubbing theater and go play it in your local cinema, they quite often don't sound very much alike. In fact, if you were to play it in 3 cinemas, they might not sound that much alike. So we thought, well, there's time to revisit the standards. And so we undertook a study, which we called the B-Chain Study Group in SMPTE, to study the situation. And then after we did a lot of prep and a lot of talking and a lot of deciding what we wanted to test, and then we went out to theaters and started testing it. And so for about a 6-month period, we visited 4 exhibition theaters and 2 dubbing theaters. And the idea was to try to find out, A, where they're at today, and B, to test different sorts of measurement techniques and all that kind of stuff that we've been talking about. So the report goes through a lot of those things. If you read through the beginning of the report, it sets it all up and postulates and shows what the study group was looking to do and why we undertook various tests. And then we did those tests. And after we did that, we realized we had a ton of data and that it was going to take a long time to crunch all that data into something meaningful. But we wanted to give SMPTE some information about what we had done. So we put together what we called a consensus report, which was only given to the SMPTE management. That was never published, which basically showed our observations, talked about the work we thought needed to be done, you know, which is some of the recommendations you see in the report that's published. SMPTE looked at it and said, yep, we agree. So you've got work to do. So here, let's turn this study group into a technology committee. And technology committees in SMPTE are the ones that actually write standards. So we went from being a study group into being a technology group, and I was continued on with the chairmanship, and got Kurt Graffy from Europe Acoustics to come along and be my co-chair, which has been fantastic. So while we have many things that this group is doing, which I'll talk about in a second, but one of the tasks that we wanted to do was finish the report part of it, actually taking this data and analyzing it, make some sense out of it, draw some conclusions, and decide where we were going from here. So that was kind of the genesis of the report. And it took us, probably almost 2 years to do that. As you can see, it's a huge report. But I think what we finally have shown here is what the state of things are today. And we didn't do this in order to criticize where everything was today. We wanted to get a baseline of where things were today so that we could decide where to go from here. And I think that we have a good baseline with this report.
Mm-hmm. Now, the report has in its title the term B chain. And I asked Brian McCarty last week about that, and he described what it is. But we now have, you sent me a graphic, and I want to show that graphic to make sure everybody understands this term. There's the A chain and the B chain in a cinema audio system in a commercial cinema. So tell us what we're looking at here.
So the A chain is mostly everything to do with getting it off of film or off of a digital cinema server and across into a processor and getting ready to be played out either picture or sound. So that's all the A part of it. The B part of it is what goes on in the theater itself, where we've now, in this case, taken the sound and we play it out through amplifiers and speakers, through a screen and into a room. So all of those things are part of the B chain, the amplifiers, the screen, the speakers, the room, the acoustics of that room are all part of what we call the B chain.
And we also have another interesting graphic. I was really happy to see this one of sort of representing what the acoustics of a commercial cinema room look like in a general sense. And so take us through this picture a little bit, will you?
Sure. Well, this shows a traditional 5.1 system in a normal theater. And what this kind of shows is what you're up against to try to reproduce something in this room that is, where everybody can hear it fairly equally and can, and then we can also deal with all of the, these arrows are showing where the sound would be bouncing around in the room. But a couple things to notice, 80% or more of the sound is coming out of that center speaker. And that's pretty well true.
80% of all the sound you hear when you go to a movie or more is coming out of one speaker.
Yeah, one and
center
that's
channel
Thing.
speaker. Yeah,
but
it is amazing.
If you remember from the beginnings of cinema, all it really had was one speaker behind the screen, and now, of course, we've got a lot more. But, the dialogue almost exclusively is played from the center speaker, unless it's an off-screen or there's a reason to pan it. Since dialogue's most of the movie, you're going to get it there. And, of course, all of the what they call spot effects, the things that happen directly on the screen come from the center. And so the center speaker really has, the most of any of the speakers in the theater in terms of what it's being asked to do. And you have to manage to get that speaker to cover everybody in the audience. So as you can see here, it's one speaker and you've got kind of a wide room that you have to cover. So there's there's coverage factor, and then there's there's the fact that when it comes out of that speaker, it goes and bounces off the ceiling, and bounces off the walls, and all those kind of things by the time it gets to the listener. So you're challenged to make sure that there's intelligibility in the room, because if there's too much echo and too much other distractions, then it's more difficult for the person in the audience to really pay attention and understand what's going on the screen.
Mm-hmm. Another challenge is getting that sound through the screen. We talked about that a bit last week, where those speakers are actually behind the screen, and so the screen has to be either perforated with tiny little holes, which is the majority case, or woven in a few cases with a material that leaves gaps between the fibers in the woven material, so that the sound can get through. That in itself is a pretty big challenge.
It is, and of course, at the very beginning of things, they didn't have perforations in screens, so the screen was even more of a filter than it is now.
Yeah.
So it's interesting because, of course, screens are most people's minds primarily there to reflect the light back to the audience so that we can get a good image. And sound traditionally has been kind of a secondary consideration of the screen. And that's certainly true now with 3D screens, which are even thicker and less transparent to audio. But yes, it's a huge challenge, and as we'll see in some subsequent slides, the screen bears a pretty big impact on the frequency response of the sound that we get.
Mm-hmm. A couple questions in the chat room. Logan 5 is asking, are these cinema speaker arrangements Wilhelm screen rated? I don't even know what that means. Do you?
I have to admit that I don't know what that means either. But,
okay, Logan 5, give us a little more then. Wilhelm screen rated. I don't know what that means. Meanwhile, we'll talk to Sandblast. We'll ask Sandblaster's question. Is this ratio of sound from speakers 80% from the center, 7% from the left and right, even less from the surrounds? Is that the same for home theater arrays, like coming off of a Blu-ray?
Sure. I mean, you've basically got, the same mix, the same proportions of the mix when you bring it home. Mm-hmm. I think, and the percentages are going to be skewed. I mean, at certain points in a movie where it's like a big music sequence, for example, you're going to get a lot more out of the surrounds and a lot more out of the left and right speakers, and the center is going to play a smaller role. But these are just a statistical average across, a general movie that has dialogue for most of it and then has other sequences.
Okay, the chat room is now informing me that Logan 5 pulled the wool over both our eyes. He was making a joke.
Okay.
He was referring to the Wilhelm scream.
Okay.
But he spelled it S-C-R-E-E-M, and I thought he misspelled screen, but instead he misspelled scream. So
nice.
I learned on this show the hard way that what the Wilhelm scream was. I didn't even know that, but it is a canned sound effect, and I misinterpreted your joke there, Logan 5. So you got me, okay? All right. So anyway, getting back to the subject at hand here, you and I, when we talked offline, you mentioned that this report was one of sort of 3 pillars of the work that you documented and what's to come. Tell us about the other 2.
Sure. When we started off on this, we knew that what we wanted to eventually do was to make new standards, make new performance standards. We knew we needed to update things because it's been, obviously technology's increased. Things have gotten much better since the original standards are written. But we didn't think we could just leapfrog straight to that. We wanted to build a foundation of things. So we've got 3 things that are basically building this foundation. The report's like the first thing, and I think that will speak for itself just to show where we're at today, and we've made some recommendations there. We also have 2 other documents. One is we're actually creating a digital pink noise standard, because believe it or not, pink noise is something that is not necessarily something that all devices do the same way. And if you're going to use it as a test signal, we figured, well, let's eliminate at least the variability in that. Let's actually standardize a digital pink signal, which we've never had. All of the literature talks about basically an analog wideband pink noise signal, which is generally done by a white noise source that you then put what they call a pinking filter on to give the pink noise slope, which we'll see in a minute, to that. And we've never actually, since the dawn of digital and where we've gone there, actually standardized that. So we decided that was an important thing. So we have that in progress. Mm-hmm. The other document that we have, we want to make a recommended practice for how to calibrate, even using the current standards, so that we can at least get a baseline of saying, with the standards as they are today, let's do the best we can. Let's all be on the same page on how we're going to calibrate things and what's important and the methods we're going to use and what we're going to go for, which hasn't really been written down in any kind of standardized way. There's various literature you can read that have been published by various places. As you can certainly go find it on the web, but we've never actually put it all down in step by step. So we're working on that right now, and I think that document is going to do quite a bit to at least get things consistent within the standards that we now have. And then I think once we've got these three documents together, then I think we're going to be ready to say, okay, now how can we push the envelope? What can we do to, up the ante and raise the bar? And, one thing that we know, and one thing you'll see right away in the conclusions of the report, is that in order to get, any further up the scale, we're going to have to really upgrade the sound systems and the B chains, actually, the whole B chain in the theater. Having better speakers and better system itself is, of course, a big part of that, but we have to deal with the screens, we have to deal with the room acoustics, everything else. So, in order to get from where we are now to another level, we have to get performance standards in place about what we expect and what we think should be attainable. And then from there, I think we can say, all right, if we can get that, now we can look at new electroacoustic standards, maybe a wider curve, things of that nature. So those are the next steps that we plan to build from this point.
Before we move on, I want to show a picture of pink noise, because we mentioned that last week as well. And this is a standard test tone. I hesitate to call it a tone because it's really noise. It's called pink noise. And as you can see here, it basically, as you move up in frequency, the amplitude decreases at a fairly linear, in a fairly linear way. And it's called pink noise. It's defined as having equal energy per octave throughout the audio band. And I find it interesting, actually, that equal energy means that as you move up in frequency, you actually decrease the level. If you were to maintain the same level across all frequencies, that would be white noise, if I'm not mistaken, right?
Correct.
Right. So you apply what you called a pinking filter to white noise to get equal energy per octave rather than equal level per octave. So you take that and you play that on the speaker system, on the B chain audio system, and then you take some measurements and you find out, the frequency response of the room. And that's kind of the basic practice of measuring a room, right?
Yeah, there's two aspects, of course. There's understanding what they call the electroacoustic response, and then there's the average sound pressure level. And right now, the general trend is to use pink noise for both of those, and that's one reason we decided that we needed to really standardize it. One reason that pink noise is chosen is because it more simulates the way the ear hears. Our ear kind of hears logarithmically, and we hear based in octaves like that. So somebody, there's a lot of studying, and this has been done, of course, over time before we got to this point, and they said that, pink noise would be a more reasonable signal to use because it would be more towards simulating the way humans hear. I mean, it's not exact, but it's more in that direction. It's a logarithmic fall off with frequency if you look at it on that graph. So that's the reason it's chosen.
So what? I know that Brian McCarty last week talked about wanting to move away from measurements like this into performance standards. What are your thoughts on that subject?
Well, I don't think it's moving away. A performance standard is when you say that this is what something should be able to deliver, right? And we certainly need that, and we haven't been literally writing those performance standards down as we should for a number of reasons. However, when you look at the expectations of the X curve and things that we're going to see in a minute, in some ways those are implied performance specifications. It's saying that these are what we are expecting to see, and so your system needs to be able to perform to this, at least at a minimum. So I think what Brian McCarty was saying is that in order, which is kind of what I said a minute ago in a different way, in order to move up the ladder from where we currently are. We need to define performance standards, and we need to understand what the equipment needs to be able to do, and probably a notch up from what it's doing right now, as we'll see. And then once I think we can get to the point where we feel that, yes, the majority of the equipment is able to attain that, then I think we'd become more comfortable saying, okay, well then, if the equipment can do it, let's write the standards in such a way to say that you would calibrate toward that. But right now, we're in no position to do so. In general, the equipment cannot barely even make the standards that we have in the X curve. So this is the problem. It's a stepwise procedure. We can't just say, all right, we're throwing everything out. We're just going to go for this new thing, because no theater can do it, or very few theaters can do it. So that doesn't do us any good. We have to really take this in steps. I think Brian was just jumping to the next level and saying, we need to define these performance standards in order to get, past where we are. And I'm basically saying the same thing.
I gotcha. All right. One of the things in the report that struck me was, as you said earlier, that the lack of consistency from one place to another, one theater to another, one dubbing stage to another. And I suppose that depended in part upon, what equipment was in the theater. I mean, I'm sure a lot of theaters have very old JBL speakers, which are not bad. I'm not trying to say they're not good, but they're quite a bit older, and maybe they don't come up to the performance standards that we're used to today. Whereas there was one system, I think you told me, where they had a modern Meyer sound speaker system, which is very high-end, very professional speakers, and a woven screen, which is kind of unusual. So there already is kind of a disparity. Does that mean that theaters with older sound systems are eventually going to have to upgrade? And that's going to be that's going to be pretty expensive, isn't it?
Well, of course, we'd certainly like to see that. And I think one of the reasons that we'd like to establish performance standards is so that theater owners would, have an idea of what their systems are being asked to do. I mean, one of the things that I'm sure we all have seen is that soundtracks have gotten more and more dynamic, more and more, just transient in nature with the move to digital. We've gotten sound now that from the dub stage to the theater, it doesn't have to go through much in the way of transfers, so you're really getting full master quality in the theater, and this is putting a high demand on sound systems. Whereas a theater that, basically was used to playing, the analog optical track, which only had limited headroom, and that was when that sound system was put in. At that time, the performance standards would have been perfectly fine for that. But, as we've moved along, and, we've moved to digital, we've moved to everything's been, moved up, as we know. Technology has moved up. We're expecting a lot more out of the sound systems, and some of these older sound systems, regardless of brand, they just simply weren't designed to do it at the time they were put in. I mean, we weren't playing soundtracks like that at that time. So I think we do have to understand that as well. So it's kind of a chicken and egg. Theaters are not likely to upgrade unless there's a reason to, and if we can establish some performance standards, but they have to be realistic performance standards that can actually be met. Then if the audiences start to go to theaters and go, gosh, that theater down the street sounded great, and this other theater that I went in just really did not sound that great, well, they're going to want to go to the new theater. So then that kind of buzz gets around, and then that theater starts getting packed, and the other theater starts getting not very many people in it. Maybe that theater would decide to put in a new sound system. It's but it's going to take that sort of thing. As long as people are buying tickets, it's pretty hard to convince people to buy new sound systems.
Yeah. I mean, certainly we've gotten a lot of comments from people on AVS about, they've gone to certain theaters and it sounded pretty bad, and that's certainly one reason why they don't go out to movies much anymore. A lot of people complain about it being too loud, and Brian McCarty and I talked about that last week, where that's one thing that has been developing over time. The average level seems to have been climbing such that now it's very painful to go to some of these really big blockbusters with lots of explosions and what have you.
Yeah.
And that's partly what you're saying, I think, though, is that the movies have become digital. The capabilities of the sound people making the movies have increased. So they're taking advantage of that, and the equipment in these older theaters can't keep up.
Yeah, I mean, the loudness question is somewhat a little bit different than my first thing, but we can talk about that too.
Sure.
Now that we're doing digital end-to-end, so to speak, where everything's being recorded digitally, we're posting digitally, we're delivering digitally, we're not going through all of these different analog transfers and things that kind of would sort of soften the transients and things like that, which we were used to. I mean, even if you go back and listen to a movie that was done, say, in the mid 90s or even early 2000s, a lot of the sounds were coming from libraries that, sound effects were coming from libraries that were based on mag or tape or something like that, and they'd been through hundreds of transfers, and just the transients on those sound effects were much lower, and people were still recording to tape and blah blah blah. So now you have situations where we're recording everything natively digitally, we're posting it digitally, we're delivering it digitally. So there's really nowhere in the chain where things are getting softened. So the full transient of things are coming through, and transients do put, that's a big ask out of a sound system when, you all of a sudden asking it to put out 100, 105 dB transient. Some of these systems were just never designed to do that. So there you go. And they fold up, and when they fold up, then they distort. And when they distort, distortion's extremely hard on the ears. And it makes it a lot more. It's funny how if you have a really good sound system and it's really clean, you can listen to things that are much louder, but they do not appear as painful. And then you're
that's a great point.
And you listen to some sound system that is barely making it when you're giving it that level, and there's like 10%, 12% distortion. Your ears get really immediately turned off to it, and so I think that's a big consideration too. But loudness per se, I mean, there is no doubt that the action movies of today are being mixed loud, and they're being mixed louder than they used to be. And this is just more, I think, a decision that's being made on the dubbing stage than anything else. And, as has been pointed out, we've got quote unquote 20 dB of headroom, and it used to be that that headroom was only used for certain key areas of the film, and now it's being used for a lot more areas of the film. So the overall feeling is that the soundtracks are creeping up in loudness. I'm not necessarily sure that dialogue is getting a whole lot louder. It might be somewhat louder than it used to be, but basically, I think most films made today, the dialogue's sort of close in level. But I think you have lots of stuff that's louder than that. And you have to remember also the filmmakers are making the films that way now. They're making long, effect sequences that just go on for minutes at a time. And so since the movie's demanding it based on the content, well, then, of course, we're mixing sound to go with that. So as we have higher percentages of action sequences in pictures, I say higher percentage of the 2 hours are devoted to action sequences, well, of course, our ears are getting more and more hit with that loud stuff.
You mentioned early soundtracks coming off of mag tape and whatever. And of course, I remembered again of the Wilhelm scream, which somebody, punked me about earlier today. Anyway.
That's a canned sound effect that would have been recorded onto film and probably had 10% distortion all of itself.
Right, already. Exactly. Well, we've been talking about the X curve, and we've got some graphics I want to show of the X curve. We talked about it also last week, but there are quite a few. It's a very important aspect of movie soundtracks because it is everywhere. It's ubiquitous in movie soundtracks. Why don't you tell us about what we're seeing here and tell us about the X curve?
Well, first of all, the X curve is not in a soundtrack. The X curve is a measurement phenomenon that happens in a room where that has a screen and things like that. So there's a lot that goes into what makes the X curve the X curve.
So movie soundtracks are not mixed in a way that sort of follows this sort of curve?
Well, I think what we can say is that movie soundtracks are mixed in a theater that follows this curve. And as such, it's expected that they be played back in a theater that follows this curve. That I think is the key operative thought here.
Okay.
And what you see in front of you here is, of course, an extremely idealized picture of things, because if you take a measurement, it never looks like this exactly. But what this is really showing you is that you have, well, it's showing you many things. The middle one is kind of the average, okay? And then you see dotted lines above and below it. That's what I call the window. And you'll see that window is basically plus and minus 3 dB, which is a common audio spec to be thinking of things as, to be either plus or minus 3 dB. So what we're saying is that the basic curve is the middle. You can be within plus or minus 3 dB of it. On the very, very low end, below 50 cycles, you know, they allow a tolerance to be less than 3 dB because there's a number of sound systems that really can't do very much below 50 cycles. So that's one of the reasons they've allowed this. And what this is kind of demonstrating to you is what you're likely to see if you measure with wideband pink noise sound coming through a screen into an auditorium, back in the auditorium, about 2/3 of the way back in the auditorium, or roughly halfway into the audience in a flat seating auditorium. So that's where all this stuff kind of came from. And
why is it that the places where you make the sound and the places where the sound is reproduced, i.e. the theaters, are rolled off at the low end and the high end?
Well, so rolled off, I think, is basically it's what's happening as a result of, well, on the high end, it's what's happening as a result of the screen primarily, which is what we showed in the report, coupled with some air loss and some things like that. And on the low end, it's basically just the capability of the sound system speakers. As you can see, you know, it's basically showing flat to 50 cycles, and then, you know, a dB down at 40. You know, I mean, these are all, that's pretty actually really dang good.
It's a gentle slope at the low end, in other words.
Yeah, I mean, the ideal curve, the one that's in the middle, is actually pretty ideal. I mean, these are, of course, talking strictly about the screen speakers right now, and you know, not the subwoofer or anything. So I think, you know, if your screen speakers are, you know, flat to 50 and, you know, only 2 dB down at 30, you're doing dang good. I mean, I think most theaters probably aren't even to that, to be honest with you.
Okay.
And that's mostly to do with the capability of the speakers and how they load to the room and things like that. On the high end, what appears to be a roll-off here is, I think a lot of it is the fact that you've got this big white filter in front of the speakers, coupled with the fact that you're some distance from the screen. So, you know, in nature, you normally, if you're far from a source, like say you're 40 feet away from something, you would expect to perceive less high end from that thing. That if someone was speaking in a room 40 feet away from you, you would hear less of the parts of it than you would if you were closer to them. I mean, that's just a natural phenomenon. And I think our ears are extremely used to that. And so, in a way, it would be sort of expected that there would be some kind of natural roll-off just over the distance from the screen speakers, even if the screen was perfectly transparent. But of course, what we're finding is most screens, other than the woven screen that you mentioned, basically are a big filter, and they cut quite a bit of high frequency. So what the X curve is showing you is what you would expect to see in a normal theater with a normal screen and the sound systems that were in effect at the time that you know, in the 70s when this was done. Now, to the credit of the standard, over time, we've widened this curve out. If you were to go back and take a look at what this curve looked like 10 years ago, if you pull up the same spec 202, but maybe an earlier version of it, I think there's a 1998 version of it. It was much more forgiving on the low end. You would find that there was a big drop off on the low end. The high end was fairly similar, although the windowing was different. They allowed a much lower window than they do now. So we've actually, over time, tightened up the spec. I think the current version came out, I want to say 2010, and I participated in that. And of course, we've been looking to try to say, well, within, you know, what the measurements are and how we're doing it in the sound systems of today, we think we can narrow the window some and whatever. So if you look at that, it's actually tightened up a lot on the low end, although there's still a fair amount of attenuation on the high end.
A good sound in the chat room is asking a question right regarding this very point. Is there pre-emphasis applied during the mix to compensate for the X curve loss in the room?
There is no specific pre-emphasis. In other words, it doesn't go through something like what LPs do with an RIAA filter or something like that, where in the mastering process they boost the high end and then, or boost the low end and cut the low end, that kind of thing. What happens is, I think that good mixers, they know what something should sound like. Basically, they know what it should be. A good mixer would never sit there and attempt to put a bunch of high end onto a soundtrack in order to what might apparently look like they should compensate for the X curve, because that's just going to cause spittiness, distortion, stridency, all kinds of problems. Good mixers understand what something's supposed to sound like, and they can mix against this curve, and they know how to make it work. So there is no literal pre-emphasis being applied, and I'm actually very thankful for that.
Okay, good. Sandblaster in the chat room is asking, wouldn't a technician setting their EQ to this curve without microphone measurement be anti-productive? Wouldn't it take wouldn't it take into effect the equipment and room acoustics? Do theaters set EQ without measuring? I wouldn't think so.
No, they don't set EQ without measuring at all. And setting EQ is an interesting thing, and I have a slide on that in a minute as well. But what I think the thing to understand about the X curve is just what you expect to see with the fact that we've got this screen and we've got this room and we've got what we've got. And we're going to be seeing something along those lines when we do that. So we can have a good quality set of speakers behind the screen, good quality sound system and everything else. We're going to see something that approximates the X curve right out of the gate, just because you've got that screen over it and you're back in the room a little bit. So, what do you do from there is quite a long, detailed discussion, and this is one of the big reasons we're writing this modern calibration document, because I think there's a tremendous amount of misunderstanding about what you're actually supposed to do when you go into a calibration. Unfortunately, there's a widespread belief that you simply EQ until you match that X curve, and then when you've matched it, now my room is calibrated. And I really think that nothing could be further from the truth. And that's a very big issue, I think, that we're having right now, because people are using a lot of EQ and compensating for a lot of things they shouldn't be compensating for. And it takes away from the naturalness of the sound, because our ears basically are really tuning in on what's coming out of the direct speakers. Our ears are extremely good at being able to focus in on what's in front of us and understand what's coming out of the speakers. So even though a microphone might show you something that looks a lot like the X curve, our ears are hearing what's coming through the screen. So there's a big balancing point when it comes to calibration and how you deal with it, which is why we're taking the time to write this document.
We've got some other X curve illustrations here, graphics to show. Let's run through them and see if there's anything more we can glean. Oh, here's an example of what a measurement might look like. Tell us about this one.
Yeah, so, as you can see, it's not that nice little flat curve that you saw in the other diagram. What you're seeing here is 5 different microphones. All those little traces on the very top are each from a different microphone, which is placed around the coverage area of the room. And each of those microphones is obviously showing you a slightly different response. And what we do in order to try to understand what the average is we actually do what we call spatial averaging on those microphones to try to get an understanding of what the general average is going to be. You can see there's a couple outlying points in here. Depending on where you are in the room, you might see some differences. But this is just to show that the X curve, this is basically showing that this room is X curve-ish, as you can see. It follows the basic shape, but none of those lines look exactly like that beautiful flat little X curve. So when a technician goes into a room to calibrate, he's looking at something a whole lot more like that. So I just thought everybody would like to see that if they hadn't done it.
Sure, exactly. Let's see. Let me pull up these diagrams myself so I can see what we're talking about here. Let's move on to number 7, and we have the effective equalization. We have 3 slides that show the effective equalization. Let's take a look at those. Tell us what we're looking at here.
There's a big misunderstanding. Some people say, oh, if I just don't EQ the room, then it's going to be flat because it's the EQ in the room that's causing the X curve. Well, that isn't the EQ in the room that's causing the X curve. The X curve is really, like I've been talking about, largely the screen and everything else. So what we have here, I'm going to show you 3 slides, and these are in the report, of 3 different rooms. And the red curve is with the equalization that someone used. Well, you know, someone had obviously calibrated the room before we got there. And so the red curve shows what they ended up with. The blue curve shows what it's like without any of that equalization being applied, which is just like hitting the bypass switch, basically. Mm-hmm. And in this particular room, we find, oh, and the green is just a quick version of the X curve, so you have it as a reference. So in this particular room, on the low end, we see that if we don't EQ it, we've got a pretty big boost. Right about, like, I think it's what, 60, 70 cycles, we've got this big boost.
Yep.
And toward the high end, we see that we're severely below the X curve. I mean, pretty severely below it. So when whoever EQ'd the room came in and said, well, I think I want to try to get rid of that big bump there at 70, so you can see they tamed it to a certain extent. And they did some tweezes kind of through the mid-range. And then on the high end, they did a fair amount of boost to try to get it somewhere up near the X curve, and it gets closer. It's still under, but it does get closer. Let's see the next graph. This is a different room, same idea. The red is the equalization someone had done, and the blue is without the equalization, and the green is the X curve. And you can see this room has kind of a bump, which was somewhat tamed as well, but not as much.
Not as much, yeah.
Yeah, and there's little jiggy-jaggies through the mid-range that we're attended to. Most notably, looks like around 500 cycles or so. And then in the upper register, this room's even worse. Without the EQ, we are well below the X curve from pretty much the beginning of the curve all the way out. It's just severely below the X curve. So
that's without EQ, which means that there was some effect in the room that was causing the high frequencies to be attenuated much more than they should have been.
Well, I mean, the room or the screen or just the capability of the drivers.
I mean,
something in the V chain. You know, something in the V chain. And what this is showing is, I'm trying to dispel the myth that, you know, it's the technician going in and equalizing that makes the shape, this high-end roll-off of the X curve. These technicians are not necessarily saying, oh, I'm going to put a big roll-off in here. They're finding that they have to really boost quite a bit to even get even close to the X curve. So what this was showing is that the performance of the B chain today, we're not ready to move on in any general sense by saying, oh yeah, we can just make the curve flatter and everybody can just do that, because, you know, we can barely make the curve that we now have, right? So I think that's a really, really important thing. So quite a bit of boost has been applied on the high end, and we're still significantly under the X curve. Now, the third one shows the theater that had the woven screen, which we've talked about, and the modern sound system. And so without the equalization, you see that the complete reverse is true. There's quite a bit of high end that exceeds the X curve, although you can see there's still a dip that comes pretty close to the X curve around 10K. But generally, it's much flatter. Generally, we're getting a lot more energy in that upper area because we are using a woven screen rather than a perf screen. And what they decided to do, which I understand, is to say, well, even though that's really cool and I really like it, it doesn't really show, you know, if we're going to work in this room, we need to be a little closer to what the other rooms are, because this was a mixing room. So we'll apply, in this case, we will actually apply some high-end EQ, some cut EQ, to get us a little bit closer to the X curve, which shows you the red line. Now, even though there was attenuation EQ applied to get there, in listening to all of these rooms, this room still had considerably more detail, even though the way it looks measure-wise in the high end looks, somewhat similar or even under the X curve. But when you actually listen, you find a lot more detail in the sound because you have this woven screen. So it just goes to show that the measurements aren't everything, that there's actually quite a bit of stuff going on that doesn't necessarily show up in these graphs.
Mm-hmm, mm-hmm. F-Loop in the chat room is saying, now I get it. He's talking about over EQ. Floyd Toole's research seems to show that in home audio, the goal is a flat first arrival response and an X-curve like tapered power response at the listening position. Is there any equivalent to flat first arrival response for theaters, or is it all about total sound power?
I think the flat first arrival is still a function in theaters. You want that first arrival to be as flat as you can get it. Again, we've got this screen in the way. But and Floyd's also done quite a bit of work. Now he was on our team and helped with the report. So I think that the power response is certainly important, but I think the first reflection is also important. The difference is in a theater, you're in a much bigger room, and that first reflection is coming at you a whole lot later. So you're really getting a whole lot more out of the speaker coming at you, and then the time delay between that and the first reflection is actually longer than it would be in your home, which is a much smaller room.
Mm-hmm. Let's just take a moment to look at the next slide, which is has to do with the subwoofer. And I just want you to point out what we're looking at here and talk to us about subwoofers in theaters.
Well, so subwoofers in theaters are extremely woolly, and if you read the report, we go on about how subwoofers really need a lot more attention, and how calibrating and dealing with subwoofers need a lot more attention. What this graph here is showing is that I think a lot of people think that all they have to do is set their subwoofer 5 dB hotter using C weighting, and that's the way it is. What it really is, and this is all explained in 202 and 200, is that on the left, it shows you what a basic RTA display would look like if you looked at it. And what you would probably find if you were using the typical 85 C weighting calibration average in a theater, is that would probably look like about 70 to 72. All those little lines on the spectrograph would probably be about that. And what they're saying is in the passband that the subwoofer has, which of course is a much smaller passband, you're going to set it higher than that. So if the passband is like 70 to 72, you're going to set it to 80 to 82. But again, that's a spectral line and not an average. So this is really the way it's done, and anyone who's gone out and calibrated subwoofers has certainly seen this before. So I just kind of put it in here as a quickie. But in general, subwoofers are much more difficult to deal with. Low frequencies are much woollier and harder to tame, and it's much more difficult to have subwoofers that aren't just one-note wonders. I mean, I think we've heard many subwoofers that just go, and that's all we really hear out of the sub.
Yeah. Yep.
And having a subwoofer that actually, has some response and actually has a little bit of musicality to it, that's much better designed subs. And so the report shows that we need a lot more work in that area, and also shows the big differences in response on subwoofers. So I think that's enough on subs for this particular interview.
Okay.
There's a lot in the report. There's a whole show on subwoofers.
On subwoofers. Exactly. Well, in the remaining 12 minutes or so of the show, I want to turn our attention to immersive audio, which is the up-and-coming thing in cinema sound, and now also in home sound with the release of Dolby Atmos for the home. It's been in the theaters for a couple of years. Oro is another immersive sound format that has been in the news lately, and is in a few commercial cinemas, and will soon, or is also going to be in home theaters as well. And I wonder if this report that you have been talking about or your goals for the future include comments about immersive audio.
Well, it does, of course. We have actually an entire working group within 25CSS that's dealing with the interoperability of immersive sound systems in digital cinema, which is its own very thick subject, which is why we created an entire working group over it. I think that in just to answer your question really quickly, we're having a hard enough time getting 5.1 and 7.1 systems in gear. Once you start having a whole lot more speakers, you can imagine the problem multiplies. So,
oh man, by orders of magnitude, it seems to me.
yeah. So we obviously have to get on the stick, and once I think we can get some standards, we'll move that up. And part of the working group's job for the immersive sound will be to apply these standards to immersive sound systems. So maybe I should talk for a minute about what makes immersive sound and audio, and then maybe what we're doing about this. Is that
Please,
a good topic?
absolutely. That sounds great.
Okay. Some of this goes back to some misunderstandings about the difference between audio and sound, right? Sound is a phenomenon that happens in the air when you have a transducer or you have someone speaking. Its air pressure hits your ear, you hear it as hearing. We all know that. Audio is actually a representation of that electrically or digitally. And I think it's important to know the difference between those two. And although we probably all kind of knew that, that's an important distinction, because when we get to immersive sound is something that comes at you in 3 dimensions, essentially. The immersive sound systems of today, they've added the dimension of height. That's really the big separating factor. So you've still got the basic 5.1 or 7.1, horizontal that we've always had. And then in addition to that, we have speakers above you. And the different systems do that in some different ways, and we'll see some diagrams of that in a minute. But the basic idea is we add that 3rd dimension of height. So when we say we have immersive sound, we're talking about that. And when you say we have an immersive sound system, we're talking about having those speakers on the ceiling and having a capability of immersing you in the sound with that 3rd dimension. Immersive audio, on the other hand, is an audio representation of immersive sound, and basically this is something that we're going to transmit to an immersive sound system and ask the immersive sound system to play it. Immersive audio all in of itself can take a couple of different forms. Usually it's, it can take channels, such as the RO system or the NHK system, NHK 22.2's channels, the RO system 11.1, that's 12 channels. So we're transmitting strictly by channels in that case.
As we have done with 5.1 and 7.1.
As we have, no difference in that. And so, channel-based essence is much the same as it's always been. And then we have a new concept. Well, it's not a new concept, but it's a concept that's been brought forward, which is the idea of an audio object. Audio objects have actually been around for quite a while, but we're starting to hear about them a lot more now in immersive sound systems such as Dolby Atmos. And an audio object is simply a piece of audio of any duration and associated metadata that tells that audio what to do. Where to be in the acoustical space, how loud it's supposed to be, how many speakers it's supposed to take up, i.e. how wide it's supposed to be, various things like that. So another component to this is that we want to be able to have immersive audio have all of those things. We want immersive audio to be able to deal with both channels and objects. And right now, the different immersive sound systems that are on the market each have a proprietary method for having the audio done. And so one of the things that we want to do in SMPTE is to standardize how that audio is defined and how that audio will then be able to be transmitted to a sound system in the theater, and then have that sound system interpret that audio and make sound out of it. That's why there's a whole interoperability involved with all of those things. Recently, we introduced something we call an aux track or an auxiliary track to the digital cinema package, and that's been standardized in SMPTE now. And what that is, I don't know how many of you have studied all of this, but basically in a basic digital cinema package, there's 16 channels that are dedicated to just regular channel audio that we've always had, and that's how 5.1 and 7.1 are delivered, and other things. And in addition to that, we now have an aux track where we can put a bit stream or basically anything we want. We defined it so we can put anything in that aux track that we want to. And that can also be put inside the package and be delivered from the digital cinema server to the sound system. And since we didn't really have any standardized way to do that up to now, we're in the process of standardizing a protocol to deliver that aux track across a line and into sound system in a way that all the different sound systems that are out there can use the same protocol. And then it allows us to put things in that aux track to deliver. And this standardized audio that we're talking about here for immersive audio is designed to go into that aux track. So what we're working on is to come up with this metadata definition that says, okay, here's a dictionary of values for the metadata. I can say that this particular thing means position, this particular thing means velocity, this particular thing means width, et cetera, all the stuff that you might have for an object, and have all these things be able to be defined in what we call a register, so that people that are building products to be able to use this interoperable bit stream knows what's going to be coming at them, and they can interpret accordingly. So the tools that we use on the mixing stage need to be able to generate this metadata. And of course, the renderers in the theaters that are attached to the immersive sound systems need to be able to interpret it. And the goal is to have this one bit stream inside the digital cinema package, inside the aux track, for delivering immersive audio. And then whatever the theater happens to have as its sound system should be able to interpret this audio and play it out.
Well, that seems a lofty goal to me, because all of these systems are Dolby Atmos and Oro and NHK and EOSono, all have many proprietary aspects to them. So how can a single standardized bit stream apply to all of them? You're going to have to get the cooperation of all these companies to make this work, aren't you?
Yeah, and they're all at the table.
Oh, good.
Which is really great. They're all at the table. And we are, besides just the literal bit stream and definitions of metadata and whatever, there's going to be an onus on the mixers now, because the mixers have to realize, well, I'm only going to get to make one mix. Right now they're making a mix specifically for the RO system, a mix specifically for the Dolby system, and so they kind of know what to have. But the studios are saying, well, look, I don't want all these extra mixes, and I don't want to have to be distributing all these extra DCPs. This is a huge financial burden, very hard to keep track of, and it's really slowing down, I think, the adoption of immersive audio. So in a lot of ways, we want to get things down to one deliverable. But the challenge for the mixers is going to be where they're basically going to have to make for lack of better terminology, immersive compatible mix. So I think they're going to have to listen to their mix on the systems they expect it to be played on, and make whatever tweaks in the mix they think are necessary to make it sound pretty good on all of those systems.
Well, we've got some diagrams here of the different immersive sound systems that are available today. Let's take a look at those.
These are some drawings that Roger Dressler did, and they're one of the reports that 25CSS put out earlier this year is a report about immersive audio, and looking at all the different sound systems and compare and contrast and what we're up against to put together a common bit stream. That report's available on the same SMPTE page as the current B-Chain report. And in that report, we report on the different sound systems that exist today and kind of compare and contrast the different speakers. What you see here is the iSono system, which I think was pretty much the first on the block. The gray speakers show you kind of what I call the ring of speakers that go all around the room, and the iSono system uses wave field synthesis between these to create kind of a holographic sound field. And then the blue speakers that you see are on the ceiling. And if you look carefully at the diagram, there's 5 rows of speakers on the ceiling that are offset. So the first 3 that are closest to you, and then the next 3 that are in the next row over are offset back a little bit from those, and the next row over is back the same way the first row is. So that's how it covers.
Kind of like a diamond pattern.
Kind of like a diamond pattern. It's the idea is to try to cover the entire ceiling in a grid, in a particularly well-defined grid. So that's the way the iSono system is approaching it. And you can see there's a number of speakers, and there's a whole lot of speakers behind the screen, as well as along the walls and on the ceiling and in the back. So let's move to the next.
NHK.
Next one is the 22.2 system that you've probably heard of. This was standardized actually in 2006 in SMPTE 2036. And what this is showing is on the 22.2 system, if you look at the screen speakers, you've got 3 speakers in the middle like we normally would have. And then you've got 2 speakers on the edge. You've got wide speakers, as they call them. Those are kind of in the middle level. Then you've got speakers below those, and you've got speakers above those.
Okay.
And then along the wall, you've got your basic surrounds. Roger didn't show the whole array of surrounds, but it would have normal amount of surrounds on the wall. And then it's got speakers along the back as well, of course. And then it's got other speakers above all of those speakers. So it has basically a height layer. So all of those upper speakers that you see in blue are an entire layer of speakers that are above the speakers in gray. So, and then as they also have speakers lower on the screen. So this is the 22.2 system that NHK has done, and some of you have probably seen demos in this system. It's a very interesting system, and it's channel based. Mm-hmm. Okay, go ahead. Next one. Now, RO3D, the way they're doing it, they basically have a 5.1 system and a 5.0 system that's above that, and then a Voice of God mono channel. So on the screen, you see the 3 speakers, and then you see 3 speakers above it. So that way, it's a little bit like the NHK system. And then on the wall, you see the basic surrounds going up. It's typical, and on the back wall you see the surrounds going, and they're typical. And then, but you see all these blue speakers all the way around the walls there, which form the height layer, along with the blue ones that are on the screen. And then you see on the ceiling, this is showing 6 speakers that are kind of centered over the audience, but that's actually in Oro. That's all one channel. The speakers are all like that just to get coverage.
Mm-hmm. And this is again a channel-based system.
This is a channel-based system.
So moving on to the next one, we get to the I guess I would call it the quintessential object-based system, Dolby Atmos.
Well, Dolby Atmos has channels and objects. So the way that the Dolby Atmos system is set up, you've got the 5 speakers behind the screen, as you see here. And then on the walls, they add 2 extra speakers sort of toward the front, because most surround speakers start about a third of the way back in the audience. But you can see with Atmos, they've got 2 speakers on the wall that are closer. So that adds kind of a whole thing down in front. And then they don't have any height speakers per se. They don't have that height layer that you see in NHK and in Oro. But they do have 2 rows of speakers on the ceiling. And those are called the top surround left and the top surround right. So in a basic, the channel kind of part of Atmos is a 9.1 system, where you've got a 7.1 system in the horizontal plane, just like you normally would. And then you've got these 2 overhead arrays of the top left and the top right. So that's where the 9 comes in. Where the objects come in is that each of these speakers is individually addressable by the renderer in the theater. So if you have an audio object and if the metadata in that object tells it to be in a particular place or to move around or whatever, it's got all of these speakers that it can move through individually. So that's how Atmos combines kind of the best of channels and objects into one thing.
You've got all of these immersive audio formats. Even without those, though, you have plenty of work to do to try and make sure that the experience that we all go to, that we all have in the theaters when we go there, is more consistent than your current report has demonstrated that it is, right?
Absolutely. The whole goal is the consistency. We want to make it so that the overall quality bar is consistent between theaters, consistent between the dubbing theater and the cinema theater, so that when we mix something, we can feel like it's being played, pretty much like that in the cinemas. That's the goal.
Now, is there another goal, which is to improve the experience as it currently exists?
Exactly. So that's kind of what I was talking about before, where we want to get consistency with what the standards are that we have, do the best that we can with what we've got, and we're not even doing the best we can with what we've got, as we can plainly see. So if we can get to that point where we're actually doing the best we can with what we've got, then we're in a position of saying, okay, now let's start ratcheting it up a little bit. Let's define higher performance standards. Let's start ratcheting the whole thing up.
And what kind of time frame are we looking at here? I mean, are we in the 1 year, 2 year, 5 year, 10-year time frame of this work?
I think that by early next year, we're going to have the documents done that I mentioned before, which is the standardized pink noise and the modern calibration document. Mm-hmm. So if those can be finished in the early first quarter of the year, which is what we're planning right now, then that'll set the stage to start moving forward in the back half of the year with, upgraded performance standards and the things I talked about earlier.
Mm-hmm. Mm-hmm.
And of course, to get those done might take another 2 years.
Yes, I imagine that's true.
Got to start somewhere, right? The immersive audio work. Yeah, the immersive work, the bit stream and all that we're talking about, that ought to finish right about the same time frame, early next year.
Mm-hmm. Well, I'm sure looking forward to checking in with you on a regular basis, finding out how things are going. It's unfortunate that we didn't have time today to talk about your day job. You work on this SMPTE committee, but that's kind of a separate thing. Your day job is basically remixing theatrical movie soundtracks for home use. And that's a whole show in and of itself. So will you come back and talk about that?
Absolutely. That'd be great.
Good. Glad to hear it. Well, I want to thank you so much, Brian Vessa of Sony Pictures, for showing us a little bit more about what this report from SMPTE, the Society of Motion Picture and Television Engineers, shows us about the state of cinema sound and where it might be going in the future. Brian, thanks so much for being here.
You're welcome. Thanks for inviting me.
You bet. My pleasure. Of course, you can get to Sony Pictures at sonypictures.com. You can also follow them on Twitter at Sony Pictures. You can find me at avsforum.com. You can email me at scott@twit.tv. And you can follow me on Twitter at htgeekscott and also at avsforum. And I thank those of you who have sent me emails with suggestions for guests to be on the show. In fact, somebody, I forget who it was right at the moment, sent me a suggestion to get Brian Vessa on the show, and here he is. So that was quite serendipitous. You can always find previous episodes of Home Theater Geeks right here on twit.tv/HTG and also on our YouTube channel at youtube.com/twit Home Theater Geeks. Next week, my guest geek is scheduled to be Wilfred von Balen, the CEO of Oro. Now, we were talking about Oro as an immersive audio system, and the guy at the head of that company will be with us next week to talk about Oro immersive audio. So that's going to be extremely exciting, and I do hope you will join me. Until then, geek out.